Alright, so here we're going to be having a look at some University Calculus 1 questions. So these come from a 2014 University Calc 1 paper. Now Calc 1 is the first year course that most undergrads in quantitative degrees take. It's different at every university. It's sort of the same in a sense. It's mostly the same content, but if you have different lecturers, they can focus on different things. This is a fairly engineering/finance focused one. So these questions are not overly pure maths-ish. They're more applied maths. The lecturers for these courses are often applied mathematicians. This is not uncommon. Certainly for this iteration of the course it was. So we're going to do these questions without the calculator. You don't have to be allowed a calculator for a Calculus 1, Calculus 2 exam. You can be prevented from having one. Often they'll just give you one so you don't complain if they stop kids from having the calculators. The uni students tend to have a tantrum and say, oh, you know, I can't evaluate things without my calculator. So they just say, fine, have the calculator. Then they write the exam in such a way that the calculator is not useful or not particularly useful. So here we have tan of 50, and we have to find out a little information about tan of 50. Well, the way we're going to do this manually is we're going to look at our tan function, which looks like this, approximately. So we'll asymptote over here, asymptote over here. Pi on 4, if this is pi on 4, we know tan of pi on 4 is 1. We get this from our special triangles. This is a known value. But pi on 4, in terms of degrees, is 45. This means 50 degrees is just slightly above pi on 4. And so whatever it evaluates to, 1.2 or something like that, it's going to be greater than 1. So tan of 50 is in fact, the answer to this question is D. It's a little bigger than 1. Now question 2, we are told to evaluate arctan, which is tan minus 1, of tan of minus 3 pi on 4. All right, so immediately students will say, oh, the arctan and the tan cancel out, and so the answer is minus 3 pi on 4. This is wrong. And the reason that this is wrong is arctan of tan of x is only equal to x in the case where x is between minus pi on 2 and pi on 2. Minus 3 pi on 4 falls outside of that span of numbers. And so it's actually not the case that the answer to this question is minus 3 pi on 4. So to find an answer, we have to actually evaluate it. So the way we're going to do that, we're going to try and find tan of minus 3 pi on 4. So we'll draw the tan function. It's up here, down here. This is minus pi on 2, and it goes down here, down here. This is minus 3 pi on 2. So minus 3 pi on 4, this is minus pi, is halfway between minus pi and minus pi on 2. This is minus 3 pi on 4. So when you're looking at this, the distance between the minus pi and the minus 3 pi on 4 is pi on 4. Right? There's a pi on 4 distance, which means this value is analogous to this value over here, where the distance from the origin to the point in question is pi on 4. This means tan of minus 3 pi on 4 is actually equal to tan of pi on 4. So this implies tan of minus 3 pi on 4 is equal to tan of pi on 4. This is important because tan of minus 3 pi on 4 you don't have a way of knowing an exact solution for. Tan of pi on 4 you do. Because if we draw our right special triangle, pi on 4, 1, 1, root 2, tan of pi on 4 is opposite over adjacent, which is 1 on 1, which is 1. So we have tan of minus 3 pi on 4 is 1. This means we are now finding, where we're essentially solving a new problem, we are now solving arctan of 1. Now arctan of 1 obviously from the special triangle is going to be what angle, when we take the tan of it, gives us 1, what's going to be pi on 4, right? So this is actually equal to pi on 4, and pi on 4 is the answer, which is B. And you can also, when you do these types of questions, you can also get a computer to evaluate these. So you can do these on your own, you can do them manually, you can try and get answers. Something like Wolfram Alpha, you can get Wolfram Alpha to confirm this, and Wolfram Alpha presents this answer as pi on 4, right? Because it knows that the arctan of the tan is not just the x if the x is outside of the range from minus pi on 2 to pi on 2. This is a very common mistake. All right. So now we'll have a look at question 3. So which of the following is the natural domain of the function? All right. So f of x is equal to the natural log of x squared plus x minus 2. So if you think of the natural domain of the function, we're going to start by assuming it's pretty much all real values, and then we're going to try and think of exceptions. So x is all real values, but what can it not be? This has to be positive, right? So this has to be greater than 0. This is our main restriction in this particular case. We really just need x squared plus x minus 2 to be greater than 0. Now, we can find when it's greater than 0 a number of different ways. We could graph this, and then we could find the points where the parabola is above the axis. And that's not a bad way to go. We could also use quadratic formula, find roots, and then infer that the values including and between the roots are going to be values that make this less than 0 because it's an upwards parabola. I'm actually going to find the roots using quadratic formula. Oh, we could factorize this actually. So we'll factorize this because it's easier. Two numbers that add to make plus 1 multiply to make minus 2. That's going to be plus 2 minus 1. X plus 2. X minus 1 is greater than 0. So these roots occur when x is minus 2. X is minus 2. And when x is plus 1. So what that means graphically is we have a parabola that passes through minus 2 and plus 1 and looks like this. This is the parabola inside the logarithm. The logarithm is only defined for these tail ends because we need the thing inside the logarithm to be positive. For the values between minus 2 and 1, the parabola becomes negative, and so we can't actually have those. They're not viable solutions in this case. So this means our natural domain is going to be x such that x is less than minus 2. We're allowed values less than minus 2 in union with x such that x is greater than 1. So this means all real values except where the bit is between minus 2 and 1, including minus 2 and 1. And so that means the answer here must in fact be A.